Hello, my name is Debbie Wetzler, and I wanted to talk to you today about how large an area redox technology really is. ASEA is growing around the world, and there are still some people who don't realize what a big area of science this really is. The little molecules that we make inside of our body is something that our company has been able to make and stabilize identically outside the human body. But these little molecules are a relatively new area of science because they weren't really able to see these molecules before about 1990. So when I first learned about this, it was about 10 years ago, and I was lucky enough to have a friend who was very, very smart. She had graduated from Johns Hopkins as a molecular biologist. She had done years of research at the National Institutes of Health. And when I took the information, I will never forget what happened that day. I put the information down in front of her, and she almost fell off her chair. She looked at me and said, "Debbie, I've been studying these molecules for 17 years, and we've had scientists from around the world come and try to do this. Are you telling me that somebody was finally able to stabilize these molecules outside the human body in a bioactive form?" And when I said yes, not knowing how big this was, she looked at me and said, "You have no idea how massive this is. This will change our field as you know it." And she went on to pull a textbook right from off of her shelf in front of her computer, and when you opened it, it was all about redox, to my amazement. And she was the first one to start explaining in detail what these little molecules could do. So she first told me that they regulate every major system in the body: the endocrine system, the circulatory system, the nervous system, the lymphatic system, all the systems, because they do this at a cellular level. Because if all the cells in those systems are healthy, then the systems will be healthy, because cells make up tissues that make up organs that make up systems. So there's between 18,000 and 80,000 peer-reviewed studies, depending on how you look it up. It's quite impressive. Since then, Dr. James Watson of Watson and Crick, who discovered the double helix of DNA and won a Nobel Prize for it, published an article in the Lancet Medical Journal stating that type 2 diabetes, cancer, and brain disorders were the lack of redox signaling molecules. He's the first one to speculate that if we had enough redox signaling molecules, we would never be sick. She also sent me this article after it happened about NIH, the National Institutes of Health, granting the Medical University of South Carolina a $10.5 million grant to open a redox research center. Then they sent $2.3 million to Cornell to open their redox research center. And of course, Harvard has their own, and they're all studying something different. So Harvard is studying the role of redox with regard to aging, cancer, and male reproduction, and disease prevention. So you can see that every different institution is studying something a little different. Vanderbilt opened theirs, Wake Forest, Rochester, the University of Colorado here in Boulder, the University of Wisconsin, the University of Nebraska at Lincoln, and several in California. And these are just in the United States, the ones that I know about. So you can see how huge this area of science is. They're all studying something different. And then just last June, there was a 19th annual Redox Congress in Paris, where doctors from around the world flew in to see what new things was happening with redox signaling molecules. And so you can see what a large area of science this is. We were just the only company to be able to tap in, to find the formula that we were able to recreate these molecules and stabilize them so that they can help our bodies heal itself. So thank you very much for listening.
Hello, this is David. And of course, if you have any questions, call me. Okay, thanks.